Right here, I would not be able to breathe because I wouldn't be able to change the pressure. So you have to plug up that hole and then I'd be able to breathe. Okay? Having said that, we do have to get through that diaphragm because we have an esophagus. And we know our esophagus has to go to our stomach. And our stomach isn't in our chest, it's in our abdomen. So we do have to get through this diaphragm. And if we look down here is our esophagus.
13-minute video.
I don't know if you can see that right down in here. Here's our esophagus coming down, and it goes through the diaphragm in that particular spot right there. That spot is called the hiatus. Okay? Sometimes, particularly in preemies, that can rip. I mean, it can rip in adults too. But the diaphragm can actually tear, so you have a hole, an actual hole, and then you have abdominal contents coming up into the chest. That's called a hiatal hernia, and they have to go in there and push it back and sew it up. Okay? So our esophagus is going to come through that hiatus right here on the other side. Okay? This is our esophagus coming through. And it attaches to this big thing here, this big J-shaped thing right here, and that's the stomach. Okay? Once that food enters the stomach, there is a purse string of muscle right at the bottom of that esophagus called the esophageal sphincter, and that closes, and that way the acid and the food that's in the stomach doesn't get washed back up onto the end of the esophagus. Sometimes that muscle doesn't function properly and people do have that reflux, and that can cause damage to their esophagus because the pH in your stomach is about 2. That's highly acidic. Okay? If we look in the stomach, you can't see it too well on this guy, it's a little bit distended, but there's extra folds of tissue in here. That's the rugae of the stomach, all those wrinkles and extra folds in there. And that allows the stomach to expand. It's like extra tissue, so that the stomach can expand when it gets full of food. Okay?
So that little tightness in the stomach is the sphincter, would you say? Like, is it, can I see
up
it?
Here, and this little part right, it looks a little bit constricted right here.
Okay.
That's the other sphincter at the other end.
Okay.
Okay? Also in the stomach, you have cells that are going to produce the gastric juice, which is primarily hydrochloric acid, and you have cells that are going to produce mucus. The stomach is lined with a really thick mucus layer to protect the stomach lining from all the acid. And if you have a diet that's high in alcohol or high in salt, or you take a lot of over-the-counter NSAIDs, those break down the mucus faster than you can repair it, and you can actually end up with breaks in the mucus so that the acid actually reaches the stomach lining, and that's an ulcer. Okay? So we got our stuff in here, we're mixing it with the acid, it's all nasty. So from the stomach, we know that that stuff is going to go to the small intestines. The small intestines does not have a mucus lining, but this has a pH of 2. So if we were to just let that all flood into the small intestines, we'd burn holes through our small intestines. So clearly that doesn't happen. So the first thing we do is we regulate flow out of the stomach. And there is a sphincter right at the end of the stomach where it meets the small intestines, and that's called the pyloric sphincter, because this little end here of the J is called the pyloric region of the stomach. Pyloric sphincter, and that's going to only let that gastric juice out in little spurts. Okay? And as soon as that stuff gets into the small intestines, we have to neutralize the acid. And that is the job of the pancreas. The pancreas is a glandular organ. This thing right here, by the way, the beef teriyaki, is the spleen. That's not a digestive organ, but it's there. Okay? And this organ right here, this right here, you can really see it pretty well on this cat still. This is the pancreas. It runs from the spleen down under the stomach over onto the small intestines. Okay? And the digestive function of the pancreas is to produce digestive enzymes. And it delivers those digestive enzymes in a very alkaline or a very basic solution. So as soon as that acid comes in from the stomach, bam, it gets hit with that pancreatic secretion to neutralize the acid. Okay? Also coming in right at the beginning of the small intestines is bile. So if we go back here, again, here's our diaphragm, and here's our huge lobed liver. Okay? That liver is actually attached to the bottom of the diaphragm to hold it up there in place. That's called the falciform ligament. Okay? And we can see this little deflated sac here. That's the gallbladder. The liver produces bile salts. Those solutions are stored in the gallbladder. Okay? So if we pull this liver up a little bit, So we can see the duct coming out of the gallbladder, the bile duct or the cystic duct. Okay, so the bile is going to come out there. You can also see what's left of ducts coming in from the liver. Those are hepatic ducts because the liver is also going to secrete some enzymes. And those join into one tube right here, and that's called the common bile duct. Okay, and that again comes in right at the beginning of the small intestines. So that's going to deliver that bile right at the beginning of the small intestines. Bile functions as an emulsifier. It breaks up big globules of fat into tiny little droplets, so it's easier for you to digest. Sometimes the bile, since it's a collection of salts, some of that salt can crystallize out of solution. It forms these little gray pebbles called gallstones, and what they do is they block this duct. That creates a lot of pressure and a lot of pain. So that's why they go in, they take the gallbladder out. You can live perfectly fine without your gallbladder, obviously, but you are advised to minimize your fat intake because you can't break the fat down as effectively, and that's going to cause a lot of gastrointestinal distress. Okay? All right, so we've got all of that stuff coming in that first part of the small intestines right here. It's not too curvy, it's not too curly. This first loop of the small intestines is called the duodenum. By the time that stuff reaches the end of the duodenum, chemical digestion is complete. It's broken down as much as we can break it down. Then all of the rest of this really curly part of the small intestines, most of this here is jejunum. And the mission of the jejunum is absorption. So we've broke it all down, now we need to absorb those nutrients. And if you look at this mesentery here, this is the mesentery, you can see all these nice blood vessels coming out. So the nutrients are being absorbed by the microvilli and then the villi into the capillaries and finally into these vessels, and then eventually it goes back through the liver. Okay, so that's the function of the jejunum, is absorption. The last little piece of small intestines, right here, again not too curly, that's the ileum. The ileum joins to the large intestines, which is this. Okay, there's less of it, but it's much broader diameter, so it's pretty easy to discern. Okay, so we have the ileum joining the large intestines, and right where they meet, there's a bump. That's actually a valve. That's called the ileocecal valve. That regulates flow from the small intestines into the large intestines. Okay, you'll also notice that there's this little sac here hanging off the end. That's called the cecum in the cat. If this were a human, we'd have our appendix hanging off of here. Okay? And if we put this in the proper orientation, like that, more or less, this would be the ascending colon, the transverse colon, and the descending colon. And that descending colon is held up actually on the back body wall by this membrane here is called the mesocolon, and that just keeps that in that proper orientation. Okay? So the function of the large intestine is to reabsorb water, and there are bacteria that colonize your large intestines that feed off of whatever organic material is left, and a byproduct of their metabolism are vitamins that we can't produce for ourselves. So we absorb the vitamins along with the water. And then finally, the waste moves to the rectum, which is down here, we can't see that yet, for storage and compaction, and then finally elimination through the anus. Okay? Okay. We also have this, what's what thing?
That right there.
That's a kidney.
Oh, okay.
That's a kidney. We also have this gooey stuff here. Okay, this is called the greater omentum. It's a fat apron that goes over the intestines. And we call it the greater omentum because it was at one time actually attached to the greater or the big curve of the stomach on the outside here, and it lays over all of this. There's also the lesser omentum, and that's the remains of that is here on the small curve, the inside curve of the stomach. That's the lesser omentum. Okay. All right. Now let's look at the pluck. Here's the sheep pluck. The pluck is simply the heart, the lungs, and the trachea of the sheep all taken out as one. What I want you to see here for now, what you need to look at here, is here's our trachea coming down, and you see we have an initial V here, the initial split. Those are the right and left primary bronchus. Okay? And then as we get into the lung tissue proper, this tube has been cut. But you can see it splits again. Those are the secondary bronchi. And then if we go further, it's going to split again and again and again and again and again until finally you get the bronchioli, which are the tiniest of the air passages, and those dead end in the alveoli, which are the little air sacs in the lungs. Okay? And they talk about the root of the lung. That is just simply where that primary bronchus goes into the lung tissue and it takes the nerve and the artery and the vein with it. Okay, so you can call that root, you can call that primary bronchus, it's fine. Okay? Then at the other end, if we go to the top of the trachea, here's the hyoid bone. Remember the hyoid bone, right? Little hyoid bone. Okay? Here are the thyroid cartilages, these big plates on either side. There's the Adam's apple. Okay? And if we look down here where it's been cut, this is the first ring of the trachea, and it goes all the way around. This is a complete ring. So this is the cricoid cartilage. Okay, the very first one. Okay? And if we look back here to see what's going on, this is the glottis, or the opening to the trachea. Okay, right there, that slit. And above it you have this leaf-like piece of tissue right here. That's the epiglottis. When you swallow, that epiglottis folds down and covers the opening to the trachea. And what lies right behind the trachea? What tube is lying right here? The esophagus. So when that epiglottis folds down like that, it actually directs the food back down into the esophagus. Okay? And if we look at our human model here, okay? Again, here's the hyoid. Okay? These are the thyroid cartilages. You can't see it very well in this model, but here would be the cricoid going all the way around. And then if you look back here, you can see that the rest of these rings are open in the back. And right here would be the esophagus, lying right in this space. Okay? This is the epiglottis. Okay, so that's going to come down and cover the trachea opening. So the food would go right behind that down the esophagus. These two pieces of cartilage is here, and someone's going to have to squeeze that. My gloves are gooey. Oh, she's good at, there you go. Just squeeze the ends of the cartilage. Squeeze them shut. Up here. Do it on the ends. See what's happening?
Oh, it's opening up.
Yep, that's moving the vocal folds inside. Those are called the arytenoid cartilages. Okay, those are attached to the vocal folds, and when those move, it moves the vocal folds. Okay? Good? Good to go. All right.